Good morning, friends. Welcome to Water Resources Engineering class. In today's class also, we discuss some more quiz questions. Yesterday, we have discussed almost 2 lectures on these quiz questions. And today also, we continue the same because the more the quiz questions you do, naturally, you are more clear about what is really the whole content and how to really go into the content actually. It helps you in taking it into the content actually. So once again, refresh yourself and then come along with me, think along with me and try to answer the questions actually. List different types of rain gauges and indicate which type of rain gauge is most commonly used in India. Because the same question is repeated actually in the yesterday's one of the lectures also. Why I have written again is that is the importance given to that question actually. So the number of times I am repeating a question means actually this is the way which is very, very important, which is mandatory, which is must actually for you to understand and really go through it actually. So list different types of rain gauges. Already yesterday we talked about the rain gauges can be classified. One is non-recording rain gauges, recording rain gauges. The non-recording rain gauges are nothing but basically the Siemens rain gauge. Whereas the recording rain gauges are weighing bucket type, tipping bucket type and float type. So total together are 4 only. One is non-recording, 3 are recording actually. And out of that actually the Indian Meteorological Department naturally which is using most commonly in India commonly is the Siemens rain gauge, which is most commonly that is used in entire India is basically Siemens rain gauge. But of the late now we are using the float type rain that means recording rain gauge also. So that but most commonly used one rain gauge means immediately you should answer it is Siemens rain gauge. What is meant by probable maximum precipitation over a basin? This also yesterday again we repeat, it's a repeated question. The probable maximum precipitation is the greatest depth of precipitation that is meteorologically possible. Whether it has occurred? No. Meteorologically possible. That's what we are imagining. We are looking into the future. So over a given area for a specified duration. It represents the upper physical limit of rainfall. And why we require this probable maximum precipitation, especially in the design of hydraulic structures such as dam, which is supposed to really serve for the population, for the people for over 100 years, 200 years. For such type of things, you need to estimate that the maximum precipitation that is possible, the greatest precipitation that is possible as per the meteorological conditions. That is what we need to understand. Especially this is used for large dams, spillways and ensures safety against extreme floods. Can you plot a hydrograph using the data of rainfall mass curve? Yesterday again this is the repeated question actually, right? A hydrograph, what is a hydrograph actually? A hydrograph, if you take it for example, on x-axis what you are going to take the time, on y-axis what will be there? This is rainfall intensity. That is what we will take it. Right? So naturally the hydrograph is nothing but a bar diagram, right? This is how basically the hydrograph looks like, right? Now that is what we have mentioned. From a rainfall mass curve, what is a rainfall mass curve actually? If I take a rainfall mass curve actually, again time versus what is here? It is cumulative rainfall. So naturally how it looks like actually, it basically it goes like this, like this. It's always a rising curve actually. So this is what we call it as rainfall mass curve. This is a hydrograph. So a hydrograph is a bar diagram showing rainfall intensity versus time. From a rainfall mass curve, that means cumulative rainfall versus time. So the incremental rainfall between two successive readings is divided by the corresponding time interval to find the intensity. So the intensities are plotted against the time. That is what we call it as hydrograph. So he has taken an example And just very simple, 10 mm rainfall occurs in 1 hour interval as 235 mm basically. The plotted intensities are 235 mm respectively. List the methods of computing average rainfall over a basin. Again, it is a repeated question. So that's a number of times basically these type of questions are repeating in the exams. That's what I want to really bring it to your notice. The main methods are arithmetic mean method, Thiessen polygon method, and isohydral method. Among these, isohydral method is considered to be the most accurate since it accounts for non-uniform rainfall and non-uniform spatial distribution of rainfall. What are the factors that influence the rate of evapotranspiration? Evapotranspiration depends on solar radiation because it depends on the evapotranspiration is nothing but evaporation plus transpiration. So that depends on the solar radiation, of course temperature, of course humidity, wind velocity, the vegetation type and soil moisture. So these are the 6 factors that govern the evapotranspiration. Higher the temperature and wind speed naturally increases the rate of evaporation, whereas the high humidity and dense vegetation reduces evapotranspiration. The climatic and physiological factors together control this process. Then excellent question. What is DRH? DRH means a direct runoff hydrograph. And how is it different from a flood hydrograph? So there are 2 things here. One is flood hydrograph. The second one is direct runoff hydrograph. The direct runoff hydrograph represents the variation of direct runoff with time due to a rainfall excess. That is the first thing. It is nothing but the direct runoff is on y-axis and the time is on x-axis. For a rainfall excess, excess means what? Already whatever the rainfall out of that, some of the things have gone into infiltration actually. So whatever is remaining flowing on the surface of the ground and just below the surface of the ground, that is what we call it as direct runoff. So if you plot the direct runoff versus time, we call it as direct runoff. What it excludes from the total thing, whatever is coming onto the ground, if you exclude the base flow, it excludes the base flow and shows only surface and subsurface runoff. A flood hydrograph means what? It takes care of surface runoff, subsurface runoff plus base flow. So always you remember, flood hydrograph means surface runoff plus subsurface runoff plus base flow. All the 3 things put together, that represents actually a flood hydrograph. Whereas direct runoff hydrograph means only surface runoff plus subsurface runoff. That represents actually, it represents direct runoff hydrograph. So from the flood hydrograph, if you subtract the base flow, you get the direct runoff hydrograph. From the flood hydrograph, subtract the base flow, you are going to get the direct runoff hydrograph. Then what is unit hydrograph and what are its applications? Unit hydrograph means it is the hydrograph of direct runoff. Please remember that wording. It is nothing but the hydrograph of direct runoff. That is the first word you should write. Resulting from 1 centimeter of effective rainfall occurring uniformly over the entire basin for a specified duration. Right? It is the hydrograph of direct runoff resulting 1 centimeter depth of direct runoff or rainfall excess, right? Occurring uniformly over the entire area for a specified duration. Applications include, what is the use of unit hydrograph? You can derive the flood hydrograph. You can determination of rainfall runoff relationships and prediction of stream flow for design of hydraulic structures. This is the utilization of the unit hydrograph. Then define synthetic unit hydrograph. Again the question is repeated. A synthetic unit hydrograph is only a hydrograph derived from empirical relations between catchment characteristics and hydrograph parameters. That's all. What are the catchment characteristics? You take it is catchment characteristics, basin characteristics, all are same. Area, slope, stream length actually. It is used to observe data are insufficient or unavailable. Synthetic hydrograph comes into picture only for ungauged locations. where the data is not available or insufficient, providing a theoretical hydrograph for hydrologic design. For any hydrologic design, if you do not have any available data to really prepare the hydrograph, then we go for synthetic unit hydrograph. That means just by giving some empirical relations, especially based on the basin characteristics such as the basin area, the basin slope, and basin, the stream, whatever is flowing in that basin, that length. Based on that, if we derive something or if you find out something using empirical equations, that is what we call it as synthetic unit hydrograph. Enumerate the types of synthetic unit hydrographs. Most popular synthetic unit hydrograph is Cinder's synthetic unit hydrograph. That is what we have studied also in our syllabus. Apart from synthetic, Snyder's thing, the other things are Clark and Mockus actually. So these are the other two actually. These are used to where observed rainfall runoff data are not available. That is the fundamental thing. And the parameters are derived from basin characteristics. Then define base flow separation. Base flow separation is the process of distinguishing base flow component. Base flow component means what? The groundwater contribution from the total stream flow hydrograph. From the total stream flow hydrograph, if you separate the base flow, that means that is what we call it as we distinguish base flow and direct runoff. That is what we call it as. This helps what for actually we do base flow separation. So naturally we want to know what is the maximum component surface runoff and just below the surface subsurface runoff. And naturally what is the use of how you can do this base flow separation. Either you can go for straight line method, two line methods, or curves extension method. Any of the things you can go and separate. Once you separate that, from there you can move into the unit hydrograph, and again unit hydrograph of different durations, all that are possible, provided first you separate the base flow. Define coefficient of permeability and specific speed. Coefficient of permeability is represented by K, and it is nothing but rate of flow of water through a unit cross-sectional area of soil under a unit hydraulic gradient. What is the difference in definition when we are talking about coefficient of permeability and coefficient of transmissibility? That is also rate of flow of water through a soil of the width actually 1 meter or unit width, right? Because there basically the thickness is fixed. Here the thickness is also basically, that's why here I used the word unit cross-sectional area of soil under a unit hydraulic gradient. In transmissibility, what I say, unit width basically, unit width of soil under a unit hydraulic gradient. This is the basic fundamental difference between permeability and transmissibility. The transmissibility is always explained only for the confined aquifer, whereas hydraulic conductivity is always explained for an unconfined aquifer. It indicates the ease with which water can move through the soil pores. The specific yield is the ratio of yield. Yield means it is the ratio of volume of water that can be drained freely by gravity to the total volume of the basically the aquifer. It reflects the water yielding capacity of the entire formation. Write the governing equation of the groundwater flow. If I want to write the governing equation for groundwater flow in two-dimensional flow, that too for steady flow if you want to take it, so naturally this is dou square h by dou x square plus dou square h by dou y square is equal to 0, and this is nothing but the Laplace equation, and this equation is derived from the Darcy's law. So at this level we have studied the Darcy's law, and there we stopped it. And if we extend this course further into the next level, wherein actually we start reading, understanding, estimating the quantities in two-dimensional flow, there we use this equation. For the time being, kindly remember the governing equation of the groundwater flow. Condition is the flow is steady actually, the aquifer is homogeneous and isotropic. So under these conditions, the differential equation which is governing the groundwater flow is dou square h by dou x square plus dou square h by dou y square is equal to 0. For unsteady flow, it is different. Where what is this h also? It is nothing but the hydraulic head. And this equation is called as the Laplace equation and basically derived from Darcy's law and continuity equation. Explain how zone of aeration and zone of saturation are different. Absolutely both are different actually. From the ground surface, if you take it, but normally there will be zone of aeration and below that actually the zone of saturation. What is the fundamental difference? In the zone of saturation, all the soil, that means the voids are completely filled with water. The soil is completely saturated. Basically, there is no question of any air in the saturated zone. Whereas in the zone of aeration, both water plus air coexist. So that is the thing. And this is more important basically from the thing. So zone of aeration lies between the ground surface and the water table, where pores contain both air and water, both if they contain. The zone of saturation lies below the water table, where all pores are filled with the water. In the case of zone of saturation, there is no question of air at all. All the voids, all the pores of soil are completely filled with water. That is what we call it as saturated zone. Whereas zone of aeration means partly with water and partly with air. That is what the thing. The plant roots actually has to be in that zone, so that actually the whatever water that is possible and air is respiration is also possible for the plant. The boundary between both the zone of aeration and zone of saturation is nothing but the water table. State Darcy's law and its limitations. Darcy's law states that the discharge through a porous media means ground basically, to the soil is proportional to the hydraulic gradient I and area A. So that means Q is proportional to, Q by A is proportional to basically it is I. This is what is the thing. Or Q by A is equal to Ki, or Q is equal to Kia. This is what the definition is. And this Darcy's law is valid only for laminar flow, and it is only homogeneous and isotropic media and for fully saturated soils. It fails for turbulent flow and highly permeable gravelly materials. State the assumptions of Dupit theory. The Dupit theory is assumptions, 6 assumptions I have listed out. Number 1 is flow is horizontal and velocity is uniform over the vertical section. The slope of the free surface is very small, so that the hydraulic gradient is equal to the slope of the water surface. Darcy's law is valid. This is the first thing you should write. The aquifer is homogeneous and isotropic. Number 2, coefficient of transmissibility is constant at all places. Number 4, the well is infinitely small, so there is no storage in the whatever water you are pumping is not from the storage of the well, it is from the aquifer only. Next, flow is horizontal and velocity in the vertical section is uniform. The slope is very, very small. So these are the 6 assumptions of Dupit theory, which is an excellent question. List out different methods of irrigation. The principal methods of irrigation, basically surface irrigation, subsurface irrigation, sprinkler irrigation, and then drip irrigation. Surface irrigation, subsurface irrigation, drip irrigation, sprinkler irrigation. So these are the 4 types of majorly the methods of irrigation. So in the surface irrigation, again we have flooding, controlled flooding, furrow method, border strip method, check basin method, like that. So especially the selection of method, which way you want to apply the water, that all depends on the soil characteristics, the crop which you are doing, which you are growing in that, and third one is the availability of water. Find the delta of a crop if the duty for a base period of 110 days is this. That means duty is given to you, base period is given to you, and he is asking to find out delta. You know the equation, but the relation between duty and delta is equal to 8.64 B by D. So 8.64 B is the base period, D is the duty. So this is the thing. Distinguish between a crop period and base period. Crop means don't bring water into picture. Crop means crop. That means plant. That's all. Then whereas base means only water. Don't bring crop. Right? When you are talking about crop period, think about crop. When you talk about base period, think about water. So crop period is the total time from sowing to harvesting. The number of days from the day you have sown the crop and you have harvested the crop. You have cut the crop and removed it. So that is the thing. That period is called as crop period. What is base period? From first watering, it reflects water. First watering to the last watering. The last watering may be 10 days before the harvesting or 15 days before the harvesting. Similarly, first watering may be much before you are sowing the plant actually. So that's why base period refers to water, whereas crop period refers to the plant. Base period is slightly less than crop period and is used in duty delta calculations. Define permanent wilting point. Wilting means actually it is as good as slowly dying basically. Permanent wilting, that means permanently died. So when define what is that, the permanent wilting is such that it refers to what? The moisture in the soil. The soil moisture content at which plants can no longer extract water. The soil moisture in the soil has reached to such a state that the plant is no longer able to extract water from the soil. In such a case, and they wilt permanently even if subsequently water is added. For example, a plant has wilted actually. Normally, because of evaporation, because of the high temperatures, even morning time, if it appears a slight wilting, and basically night time it recuperates, again by the afternoon, normally morning they will be fresh. By the evening, they will be naturally almost wilting. But at the night, because of that humidity, and naturally the soil again recuperates it and supply water to the plant. So night again it regains. On morning it appears fresh. That is what we call it as temporary wilting. Whereas permanent wilting means the plant is now, the soil moisture has reached to such a stage that the plant has already is not able to extract any water. Once it reaches to that state, even if you add water after that, it won't take anything. It has died actually already. List different causes of waterlogging. The waterlogging occurs due to, first thing is over irrigation. Over irrigation in the sense that you are now giving more and more water actually. So uncontrolled flooding. So naturally at the same time there is no proper drainage for that particular irrigation land. So over irrigation and poor drainage, that is number one. Next, number two is if the land is adjoining to any canal, the seepage from the canal continuously, naturally the land becomes waterlogged because of the water table increase up to the root zone of the crop. Impervious subsoil layers. The subsoil layers are impervious. So whatever water that comes, naturally it stays only in the upper zones. Because of that, naturally the plant is not able to, basically proper respiration is not there for the plant. Then fourth one is high water table and obstruction to natural flow. The moment water table is high or obstructing the natural flow, it happens. In all the cases, it reduces the soil aeration and crop yield. So this completes to me one more quiz actually covering all the 5 units. Thank you so much.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.